The topic for today is build and deploy to Google Cloud using GitHub Actions. And I'll be focusing on mostly using um a lot of things we have learned in the past, right? It's mostly going to be a continuation of, the entire DevOps, right? So I believe the first session we had was talking around DevOps itself. And the second session, which was taken by Marigold, we learned about different cloud providers and what they do and some of their differences. Um, in this talk, we'll mostly be focusing on Google Cloud and using a more general tool, right, which is GitHub Actions for our deployment, right? And yeah, before I go too far, I know um, we are still very young people, right? So I'm just going to say Happy Children's Day to all of us. And yeah, I think we should try to be happy even while we're trying to learn DevOps, right? We should, have some fun and act like kids sometimes because it helps. Um, because DevOps can be frustrating, right? So you need to also find whatever makes you feel like a child again. That said, let's get to the annoying parts, which is you know, deploying to Google Cloud. Before we go too far, I'll first talk about some of the things we have seen in the past, right? This is more like a refresher on what we have learned over the past few 2 weeks, I guess, 2 to 3 weeks. And if you remember correctly, we started off with a diagram that looks very similar at the top, right? So we had like a spiral diagram that shows, what the process is like for developers and operations engineers, right? When it comes to what we are doing in DevOps, right? This profession itself. And we said, developers would need to code, build, and test alongside the operations person, which is considered DevOps. And the operations person is solely responsible for releasing, deploying, operating, and monitoring systems that have been deployed, right? We mentioned different tools for all of these things, and now we are majorly part, right? You can also call it release, right? Um, and if you go down this triangle a bit, you would see something, maybe a new word for some of us, microservices, and that's something really common for most companies that you have these days, where um, people get to build their systems as small components, right? And they call those components microservices, right? So you have an e-commerce store, for example. If you have bought things from Jumia, from Alibaba, you'd imagine that at some point you have to log in, right? So that can be an account microservice. When you are searching, there can be a search microservice for a particular product. When you are trying to add to your cart, there can be a cart microservice that takes care of holding what the user has added to their cart. At the point of purchase, right, where you actually make the payments, the company might decide to also have a checkout or payment microservice. Now, the idea behind this is that you want to break down your huge system into very small components so you can easily manage them, right? And when I say manage, it goes across developers and operations, right? So you want to make it easy to build and easy to deploy, right? Um, so today we'll be building um, a very small microservice, a very tiny application that does just one thing, which is showing people a particular message, right? And the ideal way to bundle these microservices, right, is by using containers, right, which is the third part of this triangle you're seeing, right? So you might have heard of containers and things like Docker and all of that, right? Containers are basically a way to package your applications, right? And or microservices so that you can easily deploy them or you can run them anywhere easily. So just think of containers as a particular box that holds your code and configuration for that code, and that's all, right? So anybody that has your code and its configuration can run it anywhere, right? Or maybe its dependencies even can run it anywhere the button likes. And that brings us to the last part, which is places you can run, right? You can run on Microsoft Azure, you can run on AWS, you can run on Google Cloud, which is where we're running our code on today, or you can run on premise, right? In your house, for example, on a Raspberry Pi, in your own on your own local machine, right? Or even on a physical server in your house. I'm sure Marigold talked about a lot of other cloud platforms where we can run our code on in the previous week. So to take it further, one of the ways you can do CI/CD is what I'm showing you currently, right? There are multiple ways of doing CI/CD. People can do it in different ways, but this is one of the examples, right? And over here, you see that developers can have their codes on GitHub or GitLab, right? And that's where they push to whenever they want to make changes. The idea behind continuous integration, which is something we have talked about, um, is that you want to make sure that as they continuously push code to a source repositories, you have a pipeline or a workflow where you can automatically run tests and build artifacts, right? So in our case, artifact is going to be considered Docker because we are building a Docker image, right? We're not necessarily running tests, but that's something that we can do to improve our CI flow, right? What we're doing for this talk today is mostly going to be building, and we are building as a Docker image, right? Which is what you have in the third section of this image. Then from there, you move on to the deployment part. There are multiple ways you can deploy, right? You can use a bash script to deploy it to any environment or any cloud of your choice. You can use tools like Jenkins to deploy somewhere, right? Any environment, right? You can even use Terraform, which you would usually use to provision your infrastructure. You can use Terraform to modify deployments when after there's a new artifact that has been built. You can use Kubernetes, right, with things like GitOps and all of that, right, to automatically make deployments whenever changes has been made, right? And finally, you want to also make sure that after it's deployed, like we said last time, you don't just deploy and go away. You want to deploy and make sure that you have enough monitoring in place so that when things go wrong, you can easily check and fix them, right? Without having to, give yourself unnecessary headaches. So to be more specific, we'll look at what we are doing today, which is an approach we'll be exploring, right? And we have a very simple Python application, right? So a lot of us might have heard about Python. Python is a general purpose programming language, but it can be used for so many things, right? Like building applications and even writing scripts, which might be useful for you as a DevOps engineer, right? There are times where you might need to write some particular scripts to do some particular stuff, right? Python is a very good tool for that. And the next thing also is the fact that we are pushing to a Git repository, right, which is GitHub, and we are leveraging GitHub Actions and Docker to build, and we are pushing our images to Docker Hub. In this image, it shows container registry. We can also push our artifact, our built image there, right? So basically, just know that Docker is a source code, and I'll show you all of that right in a bit. And once that is built and pushed to a container registry, we take that image and we deploy it to Cloud Run. So I'll talk about Cloud Run in the next few slides so you understand where we are deploying to, basically. Yeah, please, as Gold said, you can drop your questions on the chats. I'll be happy to answer them on the fly. We don't have to wait to the end of the talk. There's also a Git repository here. So you can see if you go to github.com/thinkTech4u/DevOps you'd see all of this in code, right? You see the code version of all of this, and I'll be showing you that in a bit. To go further a bit, let's talk about let me build more on some of the things we have talked about earlier, right? Microservices. So microservices is mostly just an architectural way of building applications into small pieces. Right? And you can look at this diagram here. You can see you have multiple different applications all working together, right? And that's basically a microservice. So a microservice is just a small bit of a huge system that does a specific thing, right? And it's meant to work independently, but then it also works together. So for example, if you have one of these services down, it doesn't mean that everything is going to stop working, right? If you built your e-commerce sites with a microservice architecture and your payments microservice is down, people would be able to add to carts, log in, and do everything. But then at the point of checkout, where they're supposed to make payments, that part would not be working because the payment microservice is down, right? And that's the idea behind microservice architecture because you're able to break down your huge system into smaller bits. The next concept we should also learn is the idea of containers, right? So there's a very popular concept in cloud and DevOps, which is called cloud native applications, right? And these are mostly applications that are around things like containers, right? Um, Almost anything that is cloud native based has something to do with a container, right? Either Docker or whatsoever. Now, containers are, as you can see, I don't know if you can see the icons on the right. You see it mostly contains, things like dependencies and the application itself, right? And I'll show you a typical way of building a container. A container is majorly your source code and its dependencies, right? And even configuration sometimes, right? So say I was building an application now for a friend of mine, and I want to make it easy for him to be able to run it on his computer. All I would do is just write, I'll build as a container, and I can give him that container to run on his laptop eventually, right? Um, and that's mostly one of the best ways to be able to, build applications, right? Where you're able to bundle everything together as a single package and take that package to whoever wants to run it, right? And wherever they want to run it on. And Docker is a very good example of building cloud native applications, right? Or containerized applications, because Docker is like the industry standard on how to build and deploy um, applications into it's known as containers. Then finally, I'll touch on Google Cloud, and I'm sure Google talked about this last week, where he mentioned Google Cloud, Azure, and AWS. Google Cloud is mostly a cloud provider that has multiple services across um, different major features, like things like storage. So they have things like buckets where you can store your data for long term. They have networking facilities where you can do things like virtual private connections and a lot of complex stuff when it comes to networking. Big data, Google has multiple solutions around big data solutions and all of that. And then mostly talking about cloud and compute, they have multiple solutions that even goes down to things like serverless, and that's something we're going to be looking into today. So let's talk about where we're going to be deploying today. We'll be deploying to Cloud One, and Cloud One is a managed serverless platform on Google that allows you deploy your container, right? And why I had to go through all of this explanation was so that we have an idea what where we're deploying to, basically, right? So we'll be deploying to Cloud Run. We're deploying our container to Cloud Run, right? And Cloud Run is a serverless platform on Google Cloud that allows you deploy your HTTP containers, right? And by what I mean by that is you have your containers built, you expect them to be running an HTTP application, and you want to deploy them somewhere, but you don't want to provision the server yourself. So serverless doesn't mean that there is no server at all, right? It only means that you are not managing the servers yourself. And that's why it's called Managed Serverless Compute Platform. And this is because Google are in charge of setting up the server, putting the RAM, putting the ROM, adding a disk storage to it, configuring the network, and letting you just come and deploy your container to that particular platform. And then, since it's going to be an HTTP based container, Google is going to give you a URL or a URI where you can access that particular container that you just deployed. I'll be deploying there today. So we're not just deploying to Google Cloud, you're deploying to a serverless platform on Google Cloud, and it's called Cloud Run. Um, so yeah, what does serverless means? Serverless is mostly, like I said earlier, you're not managing the servers yourself. You're not creating them or provisioning them yourself. Um, you are only just deploying to those serverless platforms, right? And serverless is very, very affordable, right? You don't get to spend as much as platforms that run 247. Most serverless platforms have something called automatic scaling that can scale up and down based on the number of usage that it gets. So for example, if you have if you are running a serverless deployment for the bank, for example, right, and you know that the bank only works 9 to 6 every day, or maybe 8 to 5, and they only use your application when they are open, right? Imagine when they close, what will you do with sorts? If you are to deploy that to a normal service every day, you means you'll be spending money that you don't need to spend because you're going to be paying for cloud hosting for 5 p.m. in the evening to like 8 a.m. the next day, and even over the weekends entirely, right? So what you can do for such type of um deployment is to make it run on a place where you're only going to pay per usage, right? So it's only when they're using it, that's when you're going to pay. And that's what serverless gives you. You only pay per your particular usage and you don't pay for when the service is not being used. You also focus on writing your code because you don't have to think about what type of server to use, if you have to use Linux or if you have to use, a particular size of your RAM or ROM. Just focus on writing your code and let Google Cloud take care of the configuration of the server for you. It can scale up fast and scale up down, and that's basically what I meant by auto scaling, right? When you have more requests, it's going to scale up. When you have lesser requests, it's going to scale down. So there's been a lot of talk, and I think we should reduce the talk and do some action, right? So I'm going to share my screen. I'm going to share my browser so we can see everything. Can we see my screen? Can we see the GitHub page? Can anyone confirm you can see my screen, please?
Yes, I see.
Yes, we can see your cloud console.
Okay, cool.
Yes.
So this is I sent a link to the chat and you might have seen that this is it. For those that made a copy of it, I would advise you to try to update the copy you make because I just made some changes there. Um, like I said when we started the talk, right, you should try to feel like a child today and be happy because DevOps is not fun, right? There are times where it's difficult. I had so many issues, I had to fix them, and I think finally now it's working. So you need to update the code if you have fucked this to get the latest version. That's now working, right? So this code is what I'm opening here, and that's mostly where we're going to be in our demo from today. I'll try to spend just 10 to 15 minutes on this demo so I can take questions and answer those questions, right? You might not be able to follow along, so it's good to pay attention. I'm recording the call also, but then it's also good for you to try this out on your own and let us know if you have any blockers. So the first thing I want to talk about here is Dockerfile. We have talked about microservices, we have talked about cloud native applications, we have talked about containers, and this is what a typical Dockerfile looks like, which you use to create your container eventually, right? So the first thing that's happening here is because I have a Python application, I remember from the image I showed you earlier, we have a Python application, right, that we are trying to deploy. We're trying to build that image and we're deploying that to Google Cloud. The first thing I have on my Docker file is the base image. So this is considered a base image, right? I'm using an old version of Python, which is 3.7. But I think you find people using 2.9 even up to today. But yeah, this works for my application, so I don't have to change it. I'm using a stretch version. You'd find that a lot of images on Docker Hub. So I can go look for this guy. So let's go to hub.docker.com and you'd see where this is coming from. So this is being pulled from Docker Hub, right? That's the first thing I want to do. I want to pull the base image from Docker Hub. If I type Python and I click on Python here and I go to tags, you see that they have multiple versions, multiple tags. You see things like Alpine, see things like Slim, things like Buster, and even Stretch, which is what I'm using, right? If you like a particular version of Python more than the other, maybe you like 3.9, you can search for it and you'd see images specific to that image tags specific to that Python version, right? I'm satisfied with this, so I'm just going to use this. So I'm pulling this as my base image, right? And that's where I want to, that's like the image I want to work on. So after pulling this Python image, the next thing I want to do is to say, okay, now let's set up where we're going to do our work, right? Let's copy everything we have into an /app directory. Docker is smart enough to create this directory if it doesn't exist and help you copy everything you have. Copy dots means copy all these things, right? The README file, the index, the HTML file, even the Docker file itself, which is redundant, right? But then you're able to copy everything you want to copy into a particular directory. And you're able to say, okay, now any command you're running, run it inside this app, which is what we are doing here. We are saying our working directory is going to be that app directory that we copied into now. And next thing we want to do is to install our dependency. Like we said, your Docker file is mostly a combination of your code, which is this guy. We are copying all our codes inside our Docker image, right, that we built eventually. And we are also setting up our dependencies and our requirements, right? So we are saying the only thing we need you to do is install Flask. And I'll show you why. Because the option I built is based off Flask, so I need the Flask library. I'm now saying the next thing I want you to do is to use Python to run main.py. And this is because when you have a Python file, you use the Python interpreter to run that file, and you're going to get your results. This is my Python file, my Python code. It's just few lines of code. I'm not doing anything magical. I'm just using Flask. Well, that's why I'm importing it here. I'm using Flask to serve an index.html file. So Flask is a web server, right? It's a backend it's a backend language for Python, very similar to Django. If you have done PHP, then Flask is something like your code igniter, your cake. If you have done Node.js, Flask is similar to things like your Express, right? It's a backend framework for building and doing stuff. I'm not doing anything special. I'm only using Flask to serve an index.html file, and that's all I'm doing. And I'm serving it on the root directory. That's like on the homepage itself. Um, and I'm trying to listen on port 8080 by default if the user does not specify a port. So you can specify a port in your environment variables, but if you don't, it's going to serve on 8080. I'm letting it use 0000, which is more like anywhere on the internet, right? You can just serve this. You don't need a specific domain. You can just serve this anywhere on the internet. So whatever domain I pass to this guy is automatically going to serve the application, and it's going to work fine. To show you what index.html looks like, it's just welcome to my simple Flask app and some Nazi emojis, right? And yeah, we'll try to just get this deployed and see what it looks like. So this is what the application looks like, right? This is the index.html. This is the main.py. This is Docker file that builds the application for us. Now, how do we build this whole thing as a container? The first thing you need to do is to write your if you're familiar with Docker, you need to install Docker so you can build and push. So we'll talk about GitHub Actions a bit. GitHub Actions is mostly, so GitHub itself is where you push your code to, right? I'm sure we all know that. But then GitHub also has GitHub Actions, right? Which is a solution from GitHub that allows you perform some cool stuff, right? So if I come here, new workflow. So yeah, so GitHub has GitHub Actions that allows you write pipeline that does like multiple things, right? So you can have a GitHub Actions that does things like Docker image building and pushing, that does things like packaging Python um apps as Anaconda packages or something. You can have GitHub Actions that deploys to Amazon, deploys to Azure, even deploys to Google Cloud, right? Google Kubernetes Engine. You have GitHub Actions that deploys to Alibaba, on all of that, right? So and there are even multiple templates for that. You can use GitHub Actions to run code analysis on your code, do some security scanning, and a lot of other cool stuff. Now, GitHub Action is not the only solution for CI/CD, right? There are a lot of other tools like Jenkins, like Concourse CI. You can write your own bash script that does your own stuff. You can use Circle CI. You can use so many other platforms. But I'm going to be using GitHub Actions here because I want to use something outside any cloud platform. Most cloud platforms also have their own CI/CD solutions. Azure has Azure DevOps. Um, Amazon has Amazon Code Pipeline, if I remember correctly. Google Cloud has Google Cloud Build, right? I don't know for Alibaba. But then all of them mostly have their own CI/CD tools, but I want to use GitHub Actions because it's more generic and you're not tying yourself to any cloud platform. So this is how you write a GitHub Actions workflow. The first thing you need to do is just to put the name, what you want that action to be called. So mine is build, push, and deploy Docker image because I'm doing these three things here, and I'll show you where I'm doing all of them. The first thing GitHub Actions needs to know is when should it be triggered, right? So I want to trigger it on the main branch itself. Some people call their default branch master. Um, normal people call it main. But yeah, you can call it whatever you want to call it, but make sure your configuration also has the same name that you have as your default name. For the job, you need to specify all the jobs you want to run, right? So I have build and push as the only job. It runs on an Ubuntu machine. So if you are building, if you're if you're doing DevOps for a mobile developer team, you'd most likely be building on something other than Ubuntu, right? Because they would want to build maybe an iOS app, and it's possible to even build on Mac OS. So, I mean, you don't have to have a Mac to be able to build. You can use GitHub Actions and specify that you want to build against a MacBook so that you can run things like Xcode and build for iOS, right? So you can decide whatever platform you want to run on. But because all I have here is mostly bash command, I'm going to let it use Ubuntu. This is going to clone the code. So this is like the first step. Get all the code base. Then I need to log into Docker Hub. And why I'm doing this is because I am pushing to a particular registry, right? If you're only pulling an image that is public, you don't need to log in. But because I need to be authenticated to be able to push. GitHub Docker Hub needs to know that I have the valid authority to be able to push to where I want to push to, which is what I'm doing on line 21 to 26. And this is very important. So um this is where we are building and pushing the image to. And I'm using an existing GitHub Actions workflow to do this. Usually, the way you do this is mostly, I'm going to write the code for this. So on a normal, if you're not using any of this, on your laptop, this is going to be something like docker build -t. I'll need to put the tag like this, and I'll put dot to say I'm building this current directory, and then I'll now do something like docker push here, right? But because I'm using GitHub Actions, I don't need to write this too. I can just use an action that builds and pushes for me automatically, which makes it super easy, right? So you don't need to know the Docker commands yourself. And that's the good thing about GitHub Actions. And you can see that here you have multiple actions that makes life easy for you. And then the next thing I'm going to do is to also log into Google Cloud. Now I have built and push, and you can see that image is actually here. I'll show you all of that in a bit. You can see that the image is actually here. It has built the image and pushed it here over an hour ago. We're going to run the pipeline again and see. I think I ran it recently. So there should be a new image. If you look at my tag, you'd see that this tag was pushed 27 minutes ago. The next step is so now we have built and pushed to Docker Hub. How do we deploy it to Google Cloud? You need to log into Google Cloud, and this is the command you'd use to deploy it to Cloud Run on Google Cloud. So right now, I know a lot of these things might seem confusing. You don't need to know all of them now. Just understand that you can use GitHub Actions to build. Feel free to go to GitHub Actions, play around some of these existing workflows and see how they work, right? See how they perform. Some of them are actually just bash scripts that does some cool stuff. But yeah, that's up to you completely. And I'm going to just show you what it looks like eventually. But before I do that, let's make a slight change to our index.html file. So this is my actions. The last actions I ran. So maybe I pushed. The last actions I ran was able to deploy. So I'm going to click on it. It took just 1 minute, and in 1 minute, it was able to do all of these things, right? It checked out the code. That's like copy the code base, log into Docker Hub using my credentials, and I'll show you how this was configured. So logging into Docker Hub is what I did here, and I passed my username as a secret to GitHub Actions. You can choose to put the values here, But then if somebody else has access to your code, they would most likely do very bad stuff with your um Docker credentials. So it's best to put them in. So if you go to settings here, you'd see actions, click on actions. No, if you go to settings, you would see secrets and variables. Click on actions under secrets and variables, and you can configure things like your Docker username and Docker password. So instead of putting the plain values within your GitHub Actions workflow, you put them inside secrets and you reference them. Yeah, so back to the action, back to this. So we're able to log in. We build and push using the commands that we had. So you can see it builds the image, and then eventually you'd see something like pushing, 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 and then it's done. Um, and then you'd see where we logged into Google Cloud using a service account. So you can go to Google Cloud, generate a service account for your cloud platform. I'll show you how that was done. So how I did this was to come to Google Cloud here. I went to IAM. So if you have opened a Google Cloud account, you need to go to the IAM section. IAM section is where you have identity and access management, and you would always have a default service account, which is this guy, the one that says compute. You can just go down to service accounts, and once you find that guy, which is this guy here, the second one, you can click on it. When you click on it, you can click on keys and try to create a new key. So that key is going to be a JSON file that you need to add to your GitHub Actions, also GitHub Actions secrets, which is what I did here. And that is what you use to log into GitHub, right? There are multiple ways of doing this, but this is just one solution. Then finally, now that we have logged into Google Cloud, we can now make our deployment. So you can see I have made a deployment here to Cloud Run. And let's go back to Cloud Run now. So I'm going to just come to Google Cloud. I'll search for Cloud Run. And on Cloud Run, I'm just going to click on the list of Cloud Run services I have. And you can see that my deployment was made just 30 minutes ago, just when we started this talk. And so far, it has no requests. That's why you see all of these are just blank. Like I said, Cloud Run, you only pay for what you use, right? So if people are using the service multiple times, you'll be able to, you would see that you have very high traffic. If I check for, you see it gives us a URL also. I can copy this URL and try to access it. But currently this URL is protected. So what we need to do is I can just go back and fix this. So I'm going to copy this URL first, visit it. It's not going to go because it needs protection. It needs like access, but I can make it available to the public by going back, clicking on the service, and I would add principal. I would say all users. I want everybody to use access the service, and I would just say invoker, and I would allow public access. So now I've allowed public access. Means this service should be reachable externally over the internet. I think it's making that change. Let's see. Okay, do this. All users. Okay. Okay, so I'll go back and refresh this page and see whether it has applied. It hasn't yet. Let me come back here and see. Okay, I think Google Cloud is taking a while to apply my changes. Let me try something really bad. This is not proper, but I'm just going to try it. So I'm clicking on this service to see if it still needs. Okay, I think it's going to work now. Refresh this page, and yeah, you can see now it's working. We have the app showing us basically what we want to see. I'm going to send the URL to the chat so people can access it. Checking the chats, I can't see any questions yet. Let's make a slight change to this and see if it's going to get deployed. So I'm going to come back to the, so let's say I want to change this content that's being displayed, and I want to just, take away some of these emojis and just use um, a nicer one, right? Let me just use this guy, and I can say my first deployment to Google Cloud, right? And I save this. Now, once this is saved, I can just come and make a commit here. Updates HTML page, right? And I'm going to push. Now, immediately I push this thing. Remember that GitHub Actions is looking for any push that comes to the main branch. And I just push to the main branch, right? So I'm going to go back here, click on Actions, and you would see that there's a new trigger that is happening. This comes from my recent push that I just made just now, right? If I click on it, you'd see that it's currently building and pushing. If I click on that guy, it has logged into Docker Hub, which was really fast. Now it's trying to build the new Docker my changes. So if you keep an eye on Docker Hub, this was showing last push was 27 minutes ago, right? If I wait for when this is going to be done, okay, I think it's done pushing, and I refresh, you can see that now it says that last push was a few seconds ago. So it has updated the image on Docker Hub. It has logged into Google Cloud, right? You can see login successful, and it has even deployed already. So all of this happened in what, 46 seconds or so, 50 something seconds. It has logged into Docker Hub and it has deployed to Cloud Run. We can confirm from Cloud Run by going to Google Cloud. We can just go back. You can go to revisions here and you'd see that there's going to be a new revision now. You can see just now it has deployed a new version of the application. This was the one we deployed before, and this is the one we deployed now. So the good thing about Cloud Run is they also help you keep track of your deployment, right? So you can choose to say the new deployment was bad. You can click here and roll back to this guy. You can say you want all the traffic to be served by a previous guy, right? If the new one you push is not working fine. To confirm that everything is okay, you can click on our URL again, or even when I'm here, I just refresh this page, and you'd see that now it has changed, what we deployed, and we have a new deployments. So yeah, these are our first deployments of Google Cloud, and I'm going to share. So I know a lot of things I've talked about are new, things like Google Cloud, Cloud Run, GitHub Actions. I'll try to share different resources to where you can learn more about these guys on your own and try to set up, build, and deploy for different repositories using GitHub Actions, right, to maybe Google Cloud. I'll stop here and take questions. I think that'll be a good thing to do. Yeah. Okay, guys. So the first question I have here is, good morning, Teams. Thanks for the class. I'm running a Flutter apps. Which OS should I use? Looking at Flutter is looking that Flutter is cross-platform. Um, I think I've done a bit of Flutter in the past, and let me just open. I think when you're deploying to Flutter, you can do so using multiple environments, right? I'm going to share my screen and show how to. So I think I once built a Android application using a CI pipeline. I'm going to share my screen and just show that briefly. Yeah. Can you see my screen? Yes, we can. Okay, so this is an example of building and deploying. In this case, I used Cloud Build as a CI/CD and Gradle, right, which is the build tool. I believe I'm not sure, but I believe you can deploy Flutter using Gradle. Now, if you can deploy, if you can build, sorry, if you can build Flutter apps using Gradle as a tool, I'm sure you'd most likely find Gradle GitHub Actions, right? Um, and what this will mean is all you need to do is just to get that GitHub Actions and plug it um inside your workflow. And you can see that even from here, these guys are building using 3 different machines. They're building on Ubuntu, building on Mac, and building on Windows, right? Flutter you can build for multiple OS, and GitHub Actions allows you use different platforms to build. So the idea of this matrix here is that run this pipeline, but then run it one by one for each of these operating systems, right? Which is like your typical matrix where you pick one and take it against every other one. So here they pick Ubuntu first, and they do all these operations on an Ubuntu machine. Then they pick for Mac and they run it against the Mac machine, right? So it means if the code is targeted at whatever OS is building it, you get the outputs for all these 3 environments by using this Gradle. What I did here is mostly just to build an Android application using Gradle, using and Cloud Build. But I'm sure even if you take a search for that and maybe search for something like Flutter, you'd most likely find someone that is already building Flutter using GitHub Actions, right? And you can reuse their process, right? Or you can set up your own custom one if you want to write it yourself and then pass in what OS it should build on. So GitHub Actions is really good. It has a very vibrant community. You find people that are building actions for different stuff every day, right? A lot of automation can be done using GitHub Actions, right? And the best part is it's free. It has like some free usage, which you'd most likely not use up, except when you're doing maybe commercial, right? So you can go to GitHub Actions, look for different CI/CD pipelines across different workflows, and try to get one of them to work for your specific need. Yeah, I think that is. Yeah. So I'll send the link. Let me just share this link on the chat. I'll also send a link to like maybe other guides that talks about things you can do with GitHub Actions apart from just deploying. And then you'll be able to go through those lists and find things that works for you specifically, right? Yeah. So whatever you're currently working on, I think it's best to start seeing how you can automate those workflow using GitHub Actions. So if you are currently building a web app or whatsoever, try to use GitHub Actions to set up the deployments for that so that you don't have to manually have to build and push to wherever you're running your application, right? I think that would be a better way to learn by start whatever you're working on currently and try to automate things around that using GitHub Actions. Okay, do we have any other questions?